So it turns out all repeating decimals can be written as a fraction. That's why they're considered rational numbers. If you have a terminating decimal or repeating decimal, it's a nice rational answer, so it can be written as a fraction. So we're going to learn how to convert that. You might know this one. It's possible you actually know, like some students might go, oh, this is obviously 7/9. There's kind of a shortcut we use sometimes. But let's just go the old-fashioned way and figure it out here. So first, you just set x equal to 0.77 repeating. That repeats. Kind of move that down just a little bit here. So now I'm going to multiply by 10. Somebody say this is 10x, which means if I multiply by 10, that'll be 7.7. And again, that 7 is just repeating, so it just kind of keeps going. And so now I'm going to subtract. And so what happens on the left side, you have 10x minus 1x, which is 9x. And if you see on the right side, the 7's kind of cancel out there, the decimal points do. And so you're just left with 7. Well, that's pretty nice, because now to solve, you just divide, and you get x equals 7/9, which is the answer we initially said. There's kind of a shortcut. If you see 0.6 repeating, that's just going to be 6/9, which of course is 2/3 when you simplify. If you see 0.8 repeating, that's going to be 8/9, which is 8/9 actually, simplified. So you can just divide by 9 when it's just the same number repeating. That little trick doesn't work on everything, so don't try it on everything. For example, this one, right? So our little trick, divided by 9, not going to work here. But our other method will work. So again, the second thing, we're going to set x equals 0.37 with the 7 repeating. And we're multiply by 10 because one digit is repeating there. So we get 10x equals, I guess this would be 3.77 with the 7 repeating. Subtract, and we get 9x. So there is a 9 involved in this. And we get, I think, 3.4. Divided by 9, 3.4 divided by 9 is our answer, but we don't like that answer because we don't like a decimal and a fraction in the same thing. So we get 34/90 when we multiply both those by 10, which is really equal to 17/45, which I think would be our answer there. Let's try a tougher version of this. So a tougher version is when you have 2 digits repeating. So you have to do it just slightly different. So x equals 0.83. And the 8 and the 3 are repeating. So that's the difference here. So instead of multiply by 10, since I have 2 digits that are repeating, I'm going to multiply by 100. It's going to move it over 2 decimal places. So we get 83.83. The reason is now that 83 repeats, that's going to drop off when I subtract. So I get 99x equals 83. Oh, that's nice because this just all cancels. 83, 83, 83. Divide by 99, divide by 99, and you get the answer, which is 83/99. And so that's how you handle it. If there were 3 digits repeating, you would multiply the top one by 1,000, right? And then you would be able to do 3 digits. So this is kind of like an introduction to just sets here. So set is the odd numbers, 3, 5, 7, and 9, whereas B has some even and odd numbers. Some of those overlap with the other set there, which may be a thing here. So this symbol here means union. Mathematically, we also call this like an or statement. So it's like the word or. So A or B. I'm happy with anything in A or anything in B, really. So what would be in that set? The union of those two. So I need everything that's in A or anything in B. So really, that's pretty much everything. So 3, 5, 6, 7, 8, 9, and 10 would be the union of those two things. So it's got the 3, 5, 7, and 9. It's also got the 10, 9, 8, 7, 6, right? So it's got both of them. A couple of those are in both sets, right? It looks like the 9 and the 7 are kind of repeated there. but since it's or, I'm really happy with anything in A or anything in B. So any of those are considered part of that set. Now this symbol means intersection, or mathematically you'll sometimes see the word and there. So, or you could think of this as the overlap. Where do those two sets overlap? Well, there's only two numbers where they overlap on. That's when both A and B are both true. So the A, anything in A that is also in set B. So the intersection of the two would just be 7 and 9. Got it. Set builder notation looks really scary. It is read as X such that. So this such that is that symbol right there, that little bar. So X such that X is larger than 2, right? So now if you want to look at that on a number line, so here's 2. So open circle at 2, and then arrow to the right would be what it looks like on a number line. So that would be a graphical representation of that set right there. So set builder notation says all the X values that are larger than 2. So it does not include 2. So that open circle means anything bigger than 2, 2.0001, like just barely bigger than 2 would be part of that set, but 2 is actually not part of that set. So it's considered an open circle there. Let's do these kind of together. So let's first find the union of these two sets. So I'm going to kind of draw these up above here. So let me go 0, 2, and 5 here. Okay, so if I draw this one up above, so that's going to be, I'm going to draw above. This is not my answer. This is just my thinking up top. So I like to separate this from the graph. So notice I'm not going to draw this on the graph like I did before. I'm going to graph this way above. So just kind of like open circle at 2 and arrow to the right, similar to what we did a second ago. And then this one, I'm also going to graph above, not on the graph. Like normally I would kind of go on the graph, but I'm going to go up above. So 0 would be an open circle, all the way to 5, which is a closed circle there, because it includes 5. That equals sign right there means includes 5, but does not include 0. So it's kind of like in between 0 and 5, including 5, but not including 0. So now we're going to find the union of those two. So I am going to put my answer on the number line here. So the union would be the or statement. So anything that any number that's on the blue line, or any number that's on the green line is a solution. So or means a union of the two. So if I want to union both of these together, everything from the blue and everything for the green is a solution. So I would say it goes from here to here. In fact, the final answer would be X is greater than 0 would be my solution set there. If you look at it on the graph, you can kind of see, oh yeah, that's where, because anything in the blue line, like those are all solutions. Anything on the green line, those are all solutions. So all those are solutions, but nothing smaller than 0 there. Let me kind of get these so I can see them. I'm going to bring them down. Oops. There we go. Okay, so let's bring this down. Okay, so let me graph this one. Again, I like to do my thinking up above. Let me change the color there. So here's my number line. I need my 0, 2, and 5. And so I'm going to do this one in green. So open circle at 2, arrow to the right. That's not my answer. That's just my thinking. Same thing here. I'm going to do this one up above. I think there's a less than or equal to right there that didn't copy over very well when I moved it. So this is 0 is an open circle, 5 is a closed circle, and everything graphed in between. So those are the two graphs. And now I'm trying to find the intersection of the two. So this is like the overlap. Where do those two overlap? Well, they kind of overlap right in here, right? So that's my graph. So I would say an open circle at 2, and a closed circle at 5, because they do overlap at 5. They both have the point of 5, but only one of them has the point at 2 there, so they don't actually overlap. So everything in between 0 and 5. So my final answer would be 2 less than x less than or equal to 5. So you want to put your final answer. It helps to write it in graph form first to kind of like figure it out, but that would be my final answer, simplified answer of what this is. Right, it's only the numbers between 2 and 5, including 5, but not including 2. And that's how you do set builder notation problems. That's your lesson. That was very quick. And